Today, the global demand for real-time multilingual access is rapidly expanding across sectors like healthcare, diplomacy, and international business. These sectors face increasing pressure to provide services at higher speeds and lower costs. AI interpreting tools are being integrated into standard workplace setups, moving from experimental novelties to pieces of functional infrastructure. This integration is often built on the assumption that interpreting is a data transfer problem, where one stream of audio is mechanically swapped for another. While AI handles static text translation effectively, live simultaneous interpreting involves a high-pressure environment where speech is often unstructured and unpredictable. The bottleneck for AI in this setting is the mechanical reality of how language must be processed in real time to maintain accuracy. As adoption grows, the focus shifts to defining specifically where human accountability remains a structural requirement. High processing speed provides no benefit if the resulting communication is unreliable. Most AI interpreting systems operate as a linear cascade. It begins with automatic speech recognition, or ASR, which converts the speaker's audio into text. That text moves to a machine translation node, handling the transfer between languages. Finally, a text-to-speech engine delivers the synthesized audio to the listener. Because the data moves in a strict sequence, any error at the start, such as mishearing a heavy accent or filtering out speech in a noisy room, is carried through and amplified at every later stage. Systems frequently struggle with idiomatic expressions or code switching, where a speaker moves between two languages. The AI often misdetects these boundaries, leading to literal transfers that distort the intended meaning. The linear nature of the cascade means the system cannot look back to correct a misunderstood intention once the output has been generated. This engineering bottleneck creates a direct trade-off. To translate accurately, a system requires the complete context of a sentence. When a system is forced to be fast, it acts before that context is available. This leads to missed negations or a failure to capture the speaker's intent. If the system waits for the speaker to finish to ensure full accuracy, the resulting delay breaks the conversational flow and the audience's attention. Under current architectures, optimizing for real-time speed and contextual meaning simultaneously is not possible. Human interpreters manage this critical latency bottleneck through entirely different cognitive methods. Professionals use anticipation and reformulation to predict the end of a thought before it is fully spoken, using world knowledge to fill the gaps that AI cannot. Successful interpretation relies on visual feedback and room dynamics. The work occurs in a physical space, moving beyond the processing of isolated audio strings. Humans adjust for pragmatics in real time, managing politeness, irony, and cultural authority to ensure the relationship between speakers remains intact. While AI processes language data, human interpreters actively manage meaning and communicative risk at the same time. The mechanical constraints of the technology dictate how institutions govern its deployment. Automation is often appropriate for expanding basic access in low-risk settings, but it is not a default solution when safety or legal consent is involved. A risk matrix can help determine appropriate deployment. The vertical axis represents the consequences of a translation error, while the horizontal axis tracks the environmental stakes. In low-stakes environments, like informal webinars, AI can safely provide baseline multilingual participation. Medium-stakes scenarios, such as corporate negotiations, require that AI output be paired with human monitoring. High-stakes environments like courtrooms, healthcare, or diplomacy remain human-led by default to prevent catastrophic errors. Institutions that fail to map technology to these risk levels face undocumented errors and potential gaps in accountability. The profession is moving toward a hybrid model of governed collaboration between human experts and AI tools. Before an event, AI assists with terminology extraction and building domain-specific glossaries from large datasets. During an event, AI provides live assistance inside the booth by offering ASR transcripts and real-time prompts for technical numbers and names. After the event, the human professional reviews the transcripts for accuracy and audits the data to ensure participant confidentiality was maintained. The design principle is that AI should reduce the cognitive burden on the interpreter without removing human accountability for the message. In this model, human professionals oversee the deployment of these tools, managing the risks inherent in high-stakes multilingual communication.